Alright, so we're dealing with a dihybrid cross here. And so first we're going to figure out what the parental generation was. And we have a dihybrid cross, so we have two traits. We have foliage color, and we have THC level. And so one parent, it doesn't really matter which parent's purple and which parent is green, as long as one of them is. Doesn't state in the problem which is which. And the same way with THC. You have to have an 8% and an 18% level. Okay, and let's say that this is parent 1 phenotype and parent 2 phenotype. You could also have put purple with 18% and green with 8%. It would get you the same result. Okay, so we're going to cross these two parents, and when we do that, all the F1 should be purple and 18%, because they've told you for the F2s. You're gonna kind of have to work backwards from that to know that that purple is dominant to green and 18% is dominant to 8%. Okay, so that is dominant and this is dominant. All of our F1s are going to be a big P and a little p, and then a little t and a big T. Okay, so they're going to be hybrids. So then we have to set up our Punnett square to figure out what our F2s look like. So we're going to first figure out what our gametes are, and you can do that either with a fork and line method or FOIL. So one gamete will be big P, big T. We'll have another one, little p, big T. Then we'll have a big P, little t, and then a little p, little t. And we'll have the same 4 gametes for each F1. So now we're going to set up our Punnett square. And since each parent's going to have the same gametes, we're just going to write those up on our both sides here for the sperm donor and the egg donor. And then we're going to align our rows and our columns. Okay, so once you have your Punnett square completed, then you just count up the number of each genotype you have for your genotypic ratio. So we have 1 PP TT, and you'll just continue with those counts. I can't. Where the frick are my